In this experiment, the research summaries passage, students did 3 experiments to study the effects of ozone on different food colorings. And so what they did is they shined a light source through 3 different colors of food coloring and measured the absorbance with a detector over the course of about 16 minutes. So the first question, number 18, said, according to the results of experiment 3 for green food coloring, at which of the following exposure times was the absorbance measured at 427 closest to the absorbance measured at 603? So for experiment 3, 603 is one of the lines, 427 is the other line. Where do they intersect? Well, they intersected at an exposure time of about 3 minutes. So the answer for 18 was G. Number 19, a student claims that a solution of blue food coloring absorbs light more strongly at 603 nanometers than at 427 nanometers. Is the claim consistent with the results of experiment 1? For an exposure time of 0 minutes, so we've got to look at 0 minutes on experiment 1. And you see for 603, it's at an absorbance of 2, and at a wavelength of 427 nanometers, the absorbance is close to 0. So yes, because the absorbance was higher at 603 than 427. Which of the following graphs best represents the results of experiments 1 through 3 for 427 nanometers at an exposure time of 4 minutes? So we want to look at 4 minutes for 427 nanometers. For blue food coloring, it's at about 0. For yellow food coloring, it's at about 1.3. For green food coloring, it's somewhere around 0.7 or 0.8. So right away you can see that since blue is 0, F, H, and J are not good answers because they are all showing absorbance for the blue food coloring. So G was the best answer here. For 21, which of the following statements about green food coloring is best supported by the results of experiments 1 through 3? So let's look at green food coloring and compare them to the other experiments. So green food coloring, we saw absorbance in both 603 and 427 nanometers, where if you look at something like yellow food coloring, there was only absorbance at 427 and nothing at 603. And on the other end, with blue food coloring, you had absorbance at 603 nanometers, but none at 427. So green food coloring looks to be kind of a mixture of both. So that one was B. For C and D, those aren't correct because both kinds of light were absorbed, so those are not good answers. And letter A just doesn't make sense. They all reacted with O3. For 22, consider the results of experiment 1 at 603 nanometers compared to the concentration of blue food coloring in the solution at an exposure time of 2 minutes. The concentration of blue food coloring at an exposure time of 12 was what? So experiment 1, 603 nanometers. At 2 minutes, we had an absorbance of about 1.4. And at 12 minutes, we had an absorbance of close to 0. So we saw this decrease as time went on for 603 nanometers. So it was lower because absorbance was lower at 12 minutes than at 2 minutes. And the last one, 23, light at 427 nanometers is violet in color, and light at 603 nanometers is orange in color. So it might help to kind of label those lines before you look at the graphs to help you tell the difference between violet and orange. So which of the following conclusions about solution color, light color, and absorbance is best supported by the results of experiments 1 and 2? So we got to look at 1 and 2, saying that blue solutions tend to absorb violet light, while blue solutions, blue food coloring, tends to absorb orange light and not violet light, and yellow food coloring absorbs violet light but does not absorb orange light. So if we look at our answer choices here, blue solutions tend to absorb violet light less strongly than orange light, and yellow solutions tend to absorb violet light more strongly than orange light. All the other ones kind of had something flip-flopped, and D is the only one that made sense there.